Good day everyone, I am Jelaine A. Umanya. So today, let me discuss to you the experimental research. What is experimental research? When your research study is experimental, it is naturally under quantitative mode. Second, it concerned with cause and effect relationship that also involve manipulation or control of the independent variables in measurement of dependent variables. Now, experimental study uses the principles of research known as the methods of difference. It means the effect of a single variable applied to the situation can be assessed, and the difference can be determined. Hence, let me emphasize it, the experimental research is research conducted with a scientific approach using two sets of variables. The first set acts a constant which you use to measure the difference of the second set.
The most simple definition of experimental research design is: this pertains to the methods used to collect data in experimental studies. What is causality? Simply stated, causality suggests a single event the cause always leads to another single event the effect. Anderson states, causes and consequences concentrate on the relationships between phenomena, how one phenomenon affects another. In the social sciences, at least, the focus is normally on a variety determining factors, which increase the probability of a certain event occurring, rather than on a single factor. Goldhar even argues that the demonstration of causality in any rigorous sense is philosophically impossible, and he suggests that causality and explanation can be used interchangeably. An understanding of causality is essential to the proper testing of causal hypotheses or relationships and is useful in designing research studies to be rigorous as possible. The conditions for causality. In attempting to confirm causality in a relationship, one must consider the so-called conditions or factors that may exist. A necessary condition is one that must occur if the phenomenon of which it is cause is to occur. That it is to say, if X, the independent variable, is a necessary condition of Y, the independent variable, Y will never occur unless X occurs. For example, if library instruction were a necessary condition of effective library use, then the latter would never occur unless library instruction has been provided. One type of condition that can be considered, in addition to necessary and sufficient condition, is the contributory condition. Contributory conditions increase the probability that a certain phenomenon will occur, but they do not make it certain. So, if library instruction were considered to be factor likely to have the strongest effect on library use, then the other factors named, such as peer pressure, might be considered to be contributory conditions. And in fact, the combination and interaction all of the relevant factors or independent variables would probably explain effective library use. The conditions under which a given variable is a contributory cause are referred to as contingent conditions. The researcher should also be aware of the possibility of alternative conditions that might make the occurrence of a certain phenomenon more likely. Alternative conditions, in essence, refer to the different forms that a given factor or variable may take and how the factor's influence is affected by its form. A mechanism refers to the conditions that create the causal connection or the interviewing variables. Consideration of the mechanism helps us to understand how variation in the independent variable results in variation in the independent variables. Basis for inferring causal relationships. The social science researcher normally has to infer a causal relationship between two or more variables based on the data gathered. One type of evidence for inferring causal relationship is known as concomitant variation. Evidence of concomitant variation, or covariation when there are two variables, indicates that the independent variable X and the dependent variable, or assumed effect Y, are associated in the way predicted by the causal hypothesis. A second basis for inferring a causal relationship between two variables relates to the time order occurrence of the variables. To establish the necessary time order requires evidence that the dependent variable did not occur before the independent variable. One could not support a hypothesis predicting a necessary causal relationship between library instruction and effective library use if it were found that the effective library use was occurring before the patrons received any library instruction. The third basis for inferring a causal relationship is non-spuriousness, or evidence ruling out other factors as possible causes of the dependent variable. There are certain conditions that should exist, and certain kinds of inferences that must not be made. In order to support causal relationships, the most effective method for collecting the necessary evidence or testing a causal hypothesis is the experiment controlling the variables. There are three major techniques for controlling the influence of extraneous variables, two of which are intended to equate the experimental and comparison groups prior to the experiment. One technique involves holding the other variables constant. By matching or selecting subjects with the same traits for the experimental and comparison groups. Another one, which is quite similar on all characteristics or variables that are relevant or capable of affecting the dependent variable, is selected for the comparison group. The third and best technique for equating two or more groups before the experimental treatment begins is referred to as random assignment or randomization. It is a procedure used after the sample is selected, but before the experimental treatment is applied. It involves randomly assigning the subjects in the total sample to the experimental and comparison groups. Specific techniques used for random assignment are often essentially the same as those used for selecting random samples. The researcher may elect, for example, to draw names from a hat, use a table of random numbers, or employ a computer to generate a list of random numbers. What is internal validity? Internal validity refers to the possibility that the conclusions drawn from experimental may not accurately reflect what went on in the experiment itself. What is external validity? External validity is the second type of validity important to successful experimental research will be considered. External validity is important because it relates to the possibility that conclusions drawn from experimental results may not be generalized to the real world. Experimental design. Experimental research holds significant potential for the resolution of library-related problems. The testing of causal hypothesis increases our ability to explain why certain phenomena occur, and experimental research may be the method best equipped for such testing. So now let's go to the types of experimental designs, which are true experimental, quasi-experimental, and pre-experimental.
In true experimental design, these criteria are present. 1. The researcher has control over the variables, treatment, or intervention and the subject. 2. There is experimental control group. 3. Subjects are assigned to this group. True experimental design have three types. First, the pre-test post-test control group design. Second, post-test only control group design. And lastly, the Solomon 4 group design. Let us go to the pre-test post-test control group design. If we illustrate them, these are the following. First, subjects are assigned to groups. Second, pretest is given to both groups. Third, experimental group receive the treatment. Likewise, the control group does not receive the treatment. And then post-test is given to both groups. Let us put this research design into a concrete one example. So our study is quantitative one with the title Peer Tutoring, Its Effects on Reading Fluency of Senior High School Students. Now we have two groups here represented by A and then B. So the letter A, it is our experimental group. On the other hand, the letter B is our control group. Now, both of them will be given a pretest on reading fluency. However, when it comes in intervention, the experimental group only will receive an intervention, which is in this case is the peer tutoring. The control group has not intervention. Now, in post-test, they will both be given a post-test on reading fluency. So we're done with the first type of true experimental research design, the pretest post-test control group design. So now let's talk about the post-test only control group design. And post-test only control group design, this is what is inside them. First, subjects are assigned to groups. Second, experimental group receives the treatment. Third, control group does not receive the treatment. And fourth, post-test is given to both groups. So what we have noticed by in terms post-test only control group design, this type has no pretest to be given to the experimental and to the control group. Let us emphasize in post-test only control design, we still have two groups, the experimental group and control group. However, they both have no pretest. Now, the experimental group has an intervention to be applied, while the control group has no intervention, but they both have post-test.
At this point, let's go to the quasi-experimental design.
Quasi-experimental design. In this design, it is either no control group or the subject are not randomly assigned to groups.
There are few examples of quasi-experimental designs: non-equivalent control group design, time series design, equivalent time samples design, and the multiple series design.
As we noticed, the non-equivalent control group design is like a pretest post-test control group design. The other type of quasi-experimental research design is the time series design. So here, the researcher periodically observes or measures the subjects. So on pretest had multiple observations that the researchers will do. The same for the post-test with multiple observation as well.
So now let's go to the last type, which is pre-experimental research design.
Pre-experimental research design. In this design, the researcher has little control over the research, which make this design to be weak. There are three types of experimental research design. First, the one-shot case study. Now here, a single group is exposed to an experimental treatment. Then, they observe after the treatment. Another type is what we called one-group pretest post-test design. So here, the researcher just provide a comparative description of a group of subjects before and after the experimental treatment.
Lastly, the static group comparison does control relatively well for several threats to internal validity. Those controlled are history, testing, instrumentation, regression, and possibly maturation. It is not considered to be capable of controlling the threats to external validity. What is web-based experiments? Web-based or internet-based experiments are becoming more common, especially in some of the social sciences. This technique allows researchers to collect large amounts of data from widely dispersed people and locations at minimal cost. Thanks.